No doubts, ma'am.
Yes. So when you observe about the chemical change, chemical change is a permanent change in which original substance gives rise to one or more new substance with different properties is called a chemical change. Okay, so let us see now what are the chemical changes we observe in general. Okay, so folding the paper, I'll take a piece of paper like A4 size sheet paper or any other shape paper and I'll fold it or I scramble the paper. Okay, and after some time, if I take unfolded the paper properly and if I iron the paper, so I'll get a clean and unfolded, neat and without folds, any foldings, I can observe the paper. That means folding the paper is a physical change, but when we observe about the chemical change, burning of paper is comes under chemical change. Okay, the same paper I'll take, if I burn the paper is burned and converts to ash. From that ash, will I get the original paper back? From that ash, will I get the original paper back? Or can I regenerate the paper from that ash?
No, ma'am.
No, it's highly impossible. It's highly impossible. Why? Because it's
Because it's a chemical change.
Definitely. And this is also a rusted piece of iron.
Good evening,
You can
ma'am.
see here. Yes, good evening, Bhavya. Good evening. Okay, so here we can see the rusted piece of iron. So these rusted piece, so when the iron is exposed in an open surface or open area, definitely the iron is having ability to react with atmospheric air, that is oxygen and water. So it converts to ferric oxide. Ferric oxide means this brown color is nothing but ferric oxide. But we can remove it by we can remove the outer layer by using sandpaper or any other process. Understood? But at the same way, can I get the original iron from iron oxide, like from the brown color? Can I get the gray color iron?
No, ma'am.
No. Why? Because once it converts into iron to iron oxide, so definitely a new product form. The iron present in iron oxide is different from the iron present individually. Shall I show once? Children, this is iron, this is oxygen in the atmosphere, and this is water. This is iron 3, oxide, this is rust, it's nothing but rust. And this is water molecules, along with it. Okay, this is rust. So how it occurs? It occurs by using the process called corrosion. Corrosion is nothing but reaction of water and oxygen with metals is nothing but corrosion. So iron is highly corroded in nature. So it forms iron oxide. So this iron oxide,
Ma'am.
Yeah, dear, Bhavya.
Ma'am, I'm sorry to interrupt, but I really don't know what you're discussing about. So can you please tell me which topic you're discussing?
Dear, we have started about physical and the chemical changes. So till now we have discussed about the physical change because in the last few classes some are not joined. Okay. So in that reason, again we are going with the recapitulation of the previous topics in brief. So I think Priscilla is a new chair. I have not seen her in the last session. According to me, she is new for this session.
Yes, ma'am.
Yes. So I'm going like recapitulation. Like this chapter is a very small chapter. We can go in brief. So not to the boundaries with the material. We are going beyond the material. Yeah?
Okay, ma'am.
Okay, this ion is completely different from this ion. From this ion. So we can't say that here ion is there, here ion is there, both are set. No. So this ion is completely gray in color. This ion is brown in color. Understood? This ion is an element. So this ion reacting with these two to form a new compound. This compound is completely new. Here oxygen is different and here this oxygen is different. All the elements combine to form to give the rusted property only. So we can't get it back to individual elements. That's why we'll say that chemical reactions are permanent and are irreversible. Any doubts?
No, ma'am.
Yes. What happened to Bhavya? She joined and again she left. Yeah, characteristics of chemical changes. One or more new substance are formed. The chemical change is permanent and irreversible. Chemical composition properties get completely changed. You have seen how they have changed completely. This from this ion to this product. Okay, energy change occurs in chemical change. Total mass altered, but mass of the reactants is equal to the mass of products. So this is very, very important point, children. So here the mass of ion is different and here the mass of ion may be different because here the mass is given by individual element, but here the mass is given by the compound. It's a combination of different elements. But if we have seen it, for example, all together are considered as reactants. All together are considered as reactants. If I say that all together are having 20 grams of it. 20 grams. We are not going with the individual elements. We are just saying about all these are of 20 grams. But here also, though the mass has changed from this to this, but overall alternation like 20 grams only they find. Energy neither be created nor be destroyed during the chemical reaction according to the law of mass of equilibrium. Law of mass of equilibrium. Understood? There may be alteration takes place. There may be changing in the mass of this ion from the reactants to the products. But overall mass of reactants are equal to the overall mass of products. There may be exchanging or there may be alteration or there may be some changes in the masses of the individual elements present in this to this. But overall mass of reactants and the products are same. Energy neither be created, not only energy, mass neither be created nor be destroyed during the chemical reaction. Law of definite proportions, according to the law of definite proportions. Understood?